So here we have two limits, each of which having some square roots that look fairly similar. And we're going to look at the different approaches that we need to use to evaluate each of these limits. So let's start with this limit on the left. We should have actually seen something like this before. So we have a function that's under a square root. What we want to do first with any limit is quickly check if we plug in x equals 3, do we get a number or do we get something that's undefined? And if you plug in x equals 3, plug in x equals 3, you will get square root of 0 over 0. You can check that for yourself. So yes, this is a case where we need to do some limit shenanigans. And one thing we should know about things either being raised to powers or roots being taken of things is that we can actually go ahead and move this limit inside the square root. So I'm going to rewrite this as the square root of the limit as x approaches 3 of x squared minus 5x plus 6 over x squared minus x minus 6. And this inside thing is something that we've seen before and we should know how to work with. This is something where we're going to want to factor. When we factor, we're going to get something like the limit as x approaches 3 of, this will be x minus 3, x minus 2 in the numerator, and the denominator will get x minus 3, x plus 2. We notice that we get some x minus 3's that cancel out, leaving us with the square root of the limit as x approaches 3 of x minus 2 over x plus 2. And now this is suddenly something that we can evaluate at 3. So we'll go ahead, plug in 3. That's going to give us the square root of 3 minus 2 over 3 plus 2. Which will just be the square root of 1/5. And that would be our final answer. So this problem wasn't too tricky. We just needed to remember our rule that when we have either a root or we have a power, we can move the limit inside that root or power, and then we just use the same techniques that we're used to. This next one is a little bit different though, because we have a square root, but it's not over the whole thing. Again, the first thing we want to do is check what happens when we plug in x equals 3. And again, you will end up getting, in this case, 0 over 0. We'll have square root of 9 minus 3, that's 0. We'll have 9 minus 3 minus 6, that's also 0. And we can't really factor anything yet because this square root of x plus 6, well, that's under a square root. That's kind of totally separate. So we need a fancy trick to deal with a problem like this. And what we're going to do is we're going to rationalize, we're going to rationalize the numerator. Sometimes if that square root is in the denominator, we'll rationalize the denominator instead. And when we rationalize the numerator, what that means is that when I have something like, we'll say, square root of a plus b, usually the square root comes second, but we can, we'll say over c just for fun. What I can do is I can multiply both sides by square root of a minus b, and what that's going to get us is going to be this simplifies into a squared minus b squared, so we'll have a minus b squared over c times square root of a minus b. And I mean, we still have a square root somewhere, but what we did do is we were able to get rid of the square root in the numerator. And in this case, doing something like that will be enough to help us evaluate the limit. So let's go ahead and rewrite it down here. We're going to have the limit as x approaches 3 of square root of x plus 6 minus 3 over x squared minus x minus 6. And the first thing we're going to do is kind of use this trick. It's called multiplying by the conjugate. So I'm going to multiply the numerator and the denominator by square root of x plus 6 plus 3. And again, do the same thing down here. Square root of x plus 6 plus 3. The numerator will simplify nicely. This will become the limit as x approaches 3 of x plus 6, because we'll have a squared, so that's x plus 6, and then minus b squared, so that'll be minus 9, over the denominator will not simplify nicely. We will have that square root of x plus 6 plus 3 just chilling out in the denominator. But it turns out that we're still fine. So let's go ahead and do some simplification now. That numerator is really just x minus 3. And that denominator, again, this is the same polynomial we had earlier. That's going to be x minus 3 times x plus 2, just factoring that first part. And then we're going to leave our square root of x plus 6 plus 3 here. And what we notice we could do is this x minus 3 and this x minus 3 will cancel out. Be careful, when we cancel out the entire numerator, there is still a 1 up there, so don't just make it a 0 or anything. So we'll have 1 over x plus 2 times square root of x plus 6 plus 3. And since we canceled out some stuff, that's a pretty good indicator that we're probably ready to go ahead and plug in x equals 3. And in this case, yes, we are. That's going to end up being 1 over 3 plus 2 is 5 times the square root of 3 plus 6. So that's going to be the square root of 9, which is 3 plus 3, so that's going to be 6. We're going to end up with an answer of 1 over 30. So what we saw is that even though these problems both had square roots, we had to use different approaches to handle each. This first one, all we had to do was move the limit inside the square root sign, and we were golden. In this other one, what we had to do is we had to multiply by the conjugate in order to kind of clear out one of those square roots. That turned into something that we were then able to factor nicely, or at least it turned the numerator into something that cancels out nicely with something in the denominator. And once we did that, we were in good shape to just plug in x equals 3, and we were able to get our answer. So there you go. That is how we would solve these two limits.